Hey folks, let me see, just make sure that this is on. Cool. All right. Just got a stream deck, so it's seems to have worked okay. Yeah, it seems to have worked okay. Let me just make sure. Put this away here. There we go. And get these on. All right. So, good morning, good afternoon, good evening, wherever you're tuning in from. Thanks for joining me again in this stream here. We've been doing a lot of cool stuff. Hopefully, you guys had a chance to check out build yesterday, right? The build sessions started yesterday. There was a lot of really interesting, really cool content that happened when it was announced. Um, yeah. I mean, I don't know. There were a lot of sessions that I thought were great. There were a lot of announcements that I thought were really cool, such as the win. What is it? When you get where is it? Not sure if you folks saw this. There it is. Yeah, to install and manage applications. This is in the docs. So, so I thought this was cool, right? So kind of like a chocolatey like package manager, and you can install different things. I guess it's a new way to distribute packages. I wonder though if this is only for like Windows applications, or I wonder if you can, also install things like Linux or Unix tools, especially considering that WSL integration, and now you're going to be able to sort of have Linux applications running on Windows, or at least GUI applications being able to run on Windows. I wonder if you're going to be able to install those like this as well. I don't know, and that would be really interesting if you could, right? Kind of like be the one, like the sort of the one package manager. So if you're using something like Ubuntu, right, instead of using apt-get, you just use winget, and you'd be able to install things on your WSL, right, on your I guess Ubuntu or kernel, Linux kernel that's running on your Windows machine, and then at the same time, right, just being able to install, uh, being able to install uh, applications and packages on Windows, right, like the Windows apps. Yeah, so I thought that was really cool. The terminal, I had used it before, but I kind of hey, morning, John. Yeah, I do think that people are updating the dot files now. Yeah, to sort of try to match up. I haven't tried winget myself yet, so I don't know. What's I still don't know what is required to kind of turn it into a package, or to turn an application into a package that you can then deploy via or distribute via the winget tool. But yeah, it'll be interesting to to see how that works out. The terminal was also announced 1.0, just very casually dropped, and I kind of got my Matrix background going on. It's pretty cool. I mean, right now I have my default to open up to Linux, right? But then I can also do either Azure, Command Prompt, Windows. So that's useful. I mean, I guess if you're going back and forth between these shells, I can see how this could be useful. And supposedly it's faster, right? You got the GPU acceleration and other things. But Yeah, yeah. I mean, it's nice that it's all unified, right? Like you don't have to keep switching back and forth, or have if I want to use PowerShell, have like another have PowerShell open. If I want to use with WSL, I would have to have a WSL window open, right? It's just sort of unified in here. Um, but yeah, so there was that. As it relates to machine learning, though, and there were a few things. This one was one of the bigger stories, and let me see. Yeah, so this was. Let me see if I can. There we go. Okay. Yeah. So responsible machine learning. This was or responsible ML. This was kind of the bigger story at Build, at least for the on the machine learning side of things. It was kind of like front and center, and really it deals with essentially, for the longest time we've been, organizations, individuals, they've been building models, right? But you got to think the more that these models and these autonomous applications are becoming sort of entrenched in everyday life, and the decisions, the impact that these decisions have on individuals, right? You want to make sure that it's being ethical, right? And that it's being fair, and that it's making the at the very least, you're not saying that it can't make mistakes, right? I mean, even humans, right? We make mistakes, but at the very least, understand why and be able to learn from those mistakes. And typically, if you have black box models, it's really hard, right? And it's really hard to understand what these models are doing and why they're doing it. So there's a few techniques that were talked about, right? So or a few pillars that how Microsoft sees responsible machine learning and responsible ML, and one of them is this understand pillar, right? So you should be able to understand, you should be able to interpret and explain your models, both at the model level and at the individual uh, prediction level, right? So you can do that with Interpretml, which is an open source package that that allows you to do that, right? So Interpretml interpret, and this is also part of the baked into Azure machine learning. So you can just you can take advantage of it from inside of the SDK, the Azure Machine Learning SDK. Um, yeah. But in addition to that, right? Like you want to also at the same time make sure that you're assessing and mitigating unfairness in your models, right? You want to make sure um, that the opportunities and the impact of the decisions that your models are making are being equitable, right? Or at least um, they're somewhat standard, and understanding and fairness kind of go hand in hand, right? Like for example, if there's a particular feature that your models are making decisions on, first of all, you got to understand what those features are, the features that are making or impacting your model decisions, and then based on that, you kind of got to say, okay, well, is it fair for these models to be making those decisions that way, and using various techniques, and this package called FairLearn, right? I have this package as well called FairLearn. You can do that, right? And there's a few fairness assessment and mitigation techniques that you can do both at training time, or once you're done training, you can do a sort of a post processing approach, after the fact, after you've trained your model, and perhaps you may not want to expose your inputs to, or not so much that you don't want to, but you probably can't expose how the model was built. So there's a few post processing techniques that you can sort of do to go ahead and assess and mitigate the fairness of your machine learning models. Um, then what's the other one? Then you have the protect, right? And with protect, there's like, uh, it's sort of the same challenge that typically happens, or that's there, right? Is how can you preserve privacy, the privacy and the anonymity of individuals, right? Like, these models need data, right? And the more data that you give it, then the better they tend to perform, right? The more examples that you give a machine learning model, the better they'll typically perform. But at the same time, using more data could also put organizations and basically these individuals who are building these models, they could put them at risk of exposing and sort of reducing the privacy and the anonymity the of the information of the individuals whose information they're using to train these models. So there's a few things you can do to protect, right? One way that you could do it is with differential privacy, and there's this package called white noise. Let me see, white noise. So there's a package called white noise, and what this does is it allows you to use differential privacy, a technique called differential privacy, to essentially try your best to preserve the data anonymity of the data that you're using to build your models. And kind of how it works. Let me see here. Just to kind of put a picture, right? So the way that it works is, for example, let's say that you're trying to get access to some data, right? Like, let's say that you are, I don't know, you're working with Facebook data, for example, or some sort of data that's personal, both internal or external to the company. And how would you do that? Do you know if these are Microsoft research? Yeah, they are. They are, John. They are. So some of them have been collaborations. Some of them have been collaborations. Like, I think, which one is it? It's a differential privacy. I think it may be differential privacy, the one that I think they collaborated with Harvard. Let's see. Is this the one? Yeah, see, so Microsoft. Yeah, there you go. White Noise, the differential privacy platform for Microsoft and Harvard's OpenDP. Yeah, so this one came out of Microsoft Research. Um, and a few of these have come out of Microsoft Research. And again, like Microsoft Research, they're, sort of putting resources. Yeah, there's a lot of really cool stuff that comes out of Microsoft Research. I remember a few years ago, I think, I don't know if it's still true, but I think that Microsoft may have been the top, like, private employer of PhDs in the industry, which I think is really cool. I mean, I don't know if that's still true, but at one point it certainly was. So yeah, there's a lot of really cool stuff coming out. Um, so so with differential privacy, the way that it works is, instead of, like I said, so you want to get some data, right? You want to build your model, and I don't know, you want to use user data or whatever. Um, and how would you do that, right? You would just, if you're internal to the company, or however, there's either some API, or there's you write a SQL query or something like that, and you're like, select all from blah 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 blah, right? Whatever, and you get the data, you get the raw data back, right? So you're working with the raw data. Um, privacy, differential privacy, the way that it works is it doesn't give you the data, so you still submit queries, right? But you don't get back the data. What you get is an approximation, right? So, for example, if you wanted to get the, what's the total number of individuals who have bought X product, right, within my company. You're not going to get the exact number. What differential privacy does is it's going to add noise, right, to the real number, and it's going to return that approximation, right? And it's almost like 21 questions. I won't tell you the answer, but you can ask me questions to kind of get at more or less what the answer is, all right? So, but the thing is that, you might ask yourself, like, okay, well, can't I just ask a whole bunch of questions, right? Like, can I just keep asking and asking until I get to the real data, right? Like, and sure, yeah, you might. But you have this other thing called a budget store, or a privacy budget, right? And what this does is exactly what it sounds like, right? Like, you're allocated X amount of queries. It's almost like rate limiting, if you were to think about it, right? Like, it's almost like rate limiting. You're given a certain amount of I don't know, budget allocation of things, to be able to query, or like number of queries that you can make. So you got to be very mindful in how you ask your questions, such that you don't deplete the budget. Because once you deplete the budget, that's it. You can't access the data anymore, and you kind of got to work with what you got, right? So that's kind of how it prevents those sort of like, brute force type of like keep asking questions until you get the real data. You just implement a budget store, right? And then once you sort of like, if you make a request, it checks the budget store. It makes sure that you have access to this again as well. And then what happens after that is you get the real data, but then there's that noise that gets added to it. Like, there's different techniques that you can add noise to. You create a report, and a report is just the response, right? That you're gonna get the response with noise, and that's what you would use for your analyses, right? And how should you implement these? Like, it depends, right? It depends on many things. But the main one, right, has to deal with the reliability of the data. Like, it's like, okay, well, uh, there's many things that you have to consider, but in this case, it's you have your privacy on one hand, and you have reliability, or how trustworthy is the data that I'm getting, right? Because, for example, if it's like, how many customers bought X product, right? And let's say that the real answer is 50, but then once you add noise, it comes back to 100, right? You can't really trust that data, because now it's like it's sort of like it's way off what the real number is. And at that point, like, any analyses or any models that you build off of this data, it may not be right, because they may be under or overestimating what the true value is, right? So you always got to kind of like balance those between, it's like, okay, well, how can I provide the maximum privacy for my users, while at the same time having a relatively high level of accuracy. And typically, right, if you want to build private systems, you'll rely on the side of privacy and take a hit on accuracy or reliability, but and make that be known, right? Like, hey, like, within X amount, kind of like confidence intervals, within X degree of certainty, we can say that this analysis, or the results from this analysis are correct, right? But yeah, so that's really cool. It's really nice, and there's the white noise package that allows you to do that. And then also, along with protecting, right? So you want to be able to protect your data. So let's say that you're in an environment where you can't trust anybody, right? And you want maximum security, maximum privacy. What do you do? So in that case, what you have is something called homomorphic encryption. Wow, I've been rambling for like 20 minutes. I should turn this into a talk. So what you have is homomorphic encryption. Is this the one that has a nice picture? Yes, yes, yes. Okay. So homomorphic encryption is this technique that performs operations on encrypted data. Um, it performs operations on encrypted data, and the only one that has access to the real data is you as the data owner. So typically, right, in a traditional scenario, kind of this is what's showing you what's being shown to you here on the left, right? So you go, you get the real data, you encrypt it, you send it over to some sort of cloud provider, or you send it somewhere, right, for operations to take place. Um, in order for the data to, or for the operations to take place on the data needs to be decrypted, right? And it's at this, and it gets decrypted. It performs the operations, generates a result, encrypts it back, sends it back to you, the result, and then you have to decrypt it, right? So if within this area here, right, what if you can't trust this place where you're sending your data to, right? What if you can't trust that third party that's going to be performing operations on your data? Homomorphic encryption, what it does is it kind of still goes through the same process. So you have a key, like a master key, and you encrypt your data. You send it over. The difference is the data never gets decrypted. The operations take place on the encrypted data, and then the encrypted result is returned back to you. And only you, with the master key owner, as the master key owner, can decrypt that data, right? So now your data hasn't been decrypted or exposed at any point when it's being used by some sort of third party, all right? And the way that you do that is it's this. So the technique is called homomorphic encryption, but one way that you can do it is through Microsoft Seal, all right, which is also a a Microsoft research project. So yeah, I mean it's a really neat thing. Um, and then if you go back here, right, then you have the control. So things like DevOps, right, having like an ML ops, where you have some sort of audible trail, and you can basically inspect what's going on with your models, and you have some sort of record of what's happening. Um, that's kind of the control piece. You also have this other thing called data sheets, and what data sheets are, they're basically like annotations for uh, they're annotations for your data sets. So um, there's this organization called About ML, and it's some sort of like consortium. Uh, it's some sort of consortium of companies in the industry and different organizations that are getting together to try to figure out, well, how can we be as transparent as possible in the documentation of um, assets created as part of a machine learning lifecycle, right? So your model, your data sets, um, all the things that get generated as part of and that are used as part of the machine learning lifecycle. Um, you want to make sure that you document those so that it's so that there's that sort of transparency there, right? And that, if somebody were to misuse any of the artifacts in 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 that were generated as part of your life cycle, right? There's some way to sort of be like, hey, like this is what we said the intended use was. This is how the data was used. Here's all the caveats. If you went ahead and used it this way, that's kind of on you type thing. And it's also, if somebody's new to a project, right? Just like standard documentation with development processes, it provides you with a way to share knowledge, right? So if we take a look real quick here, like for an example of these, face API transparency note, right? So this is something called data sheets for models. And in this case, like face recognition is important, creating a system fits purpose, blah, 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 face API, which choice you make, okay. But what we're interested in, this is a data sheet, right? And notice how it tells you all these things, right? The basics. What are the terms? that you need, right? Functions. There's the detection, there's the verification, and the verification piece of the face API, it builds in detections and addresses. Are these two images the same person? So here it's telling you like what does this do, right? It tells you about accuracy errors, right? How accurate it is. It tells you best practices for improving accuracy, right? How to best use the model. So it's just kind of like how could I say it? Like it's like an instruction manual, if you will, for models and for assets that are generated as part of the machine learning lifecycle. So yeah, I mean it's all really cool, and I think over some of the stuff is out there already, and as with many things, right? Like it can only get better. But it's really cool to see that individuals now have some way of implementing or some way of starting to think about these things that while they may not be in everyone's minds, or they are maybe in people's minds, uh, in the past there may not have been actionable ways that you could go ahead and start implementing these types of practices inside of your machine learning lifecycle. So yeah, definitely check it out and play around with it. At the moment, I think that they're only available for Python. So from a .NET standpoint, well, most of these are sort of .NET. Seal is actually where's GitHub? Seal. Seal is actually it's on GitHub as well, and there are .NET samples for it. So I think it's built in C++, but if we go here to .NET examples, there's all these samples that I believe you could run. I haven't tried it myself, but the .NET version, but it's really interesting. You should definitely check it out and provide feedback. Okay, so that's one of the cool things. I literally spent 20 minutes on this, and I did not intend that. Probably turn into a talk at some point. The other cool thing that was there at build, runtime training. So you can use the Onyx runtime, right? What the Onyx runtime is kind of what it sounds like. It's a runtime for Onyx models, and traditionally, it was traditionally this was something that was used only for inferencing, right? So for making predictions. Now, however, you have the ability to speed up training as well, because now you can use the Onyx runtime to train. And as you can see, what the claims here are that it can train your models up to 45% faster, which is cool. It's nice, right? Here's some comparisons that they did. Let me see. I don't know if they have. Yeah, I don't know if they have much information, but the main point of the story is that you're going to be able to now use the Onyx runtime to train your models. So this is definitely something that we like to keep an eye on. Hey Daniel, yeah, this is something that we definitely like to keep an eye on, considering that we could use Onyx for inferencing now, and actually ML.NET, it uses the Onyx runtime. It binds to make predictions and make use of the Onyx models inside of ML.NET. So now that the capability for training is there, it might be something, like I said, worth keeping an eye on. But yeah, this is really, really cool stuff. And I think, yeah, those were some of the things that I thought were really cool at build yesterday. Some of the announcements, but again, there's tons of stuff. I don't know if you folks got to see that, where they use .NET Interactive, right, which is what we've been using on these streams for. Let me see, code conversations. So during Scott Hanselman's keynote, there was this thing where it was using Microsoft Teams and .NET Interactive, which is what we've been using on the stream for Jupyter Notebooks, right? That Jupyter Notebook kernel. And they use that to run C# inside of Teams, Microsoft Teams, right? How you would use this, I'm sure that there are ways, right? Like maybe in like some sort of teaching scenario, right? Like as well, especially now, right, that everything's virtual. um, Now you could have what's it called, like the virtual whiteboards, right? So instead of going in for an interview and doing like a whiteboard session or a code session, um, doing those in person, right? You could probably use Teams to do some live coding, whiteboard interview style sessions or things of that sort. But nonetheless, it's really cool. It's really interesting. And yeah, you guys should check it out. It's Code Conversations. That's the name of the repo. Um, but yeah, there's tons and tons of stuff that was announced. That was really cool. Um, Something else that I thought was interesting. Blazor WebAssembly is now available, GA, right? Generally available, which I thought that was really cool. All right, so now what this means is you can run WebAssembly, the WebAssembly version of Blazor. I mean, not that you couldn't before, but now this is sort of the stable or the official release version, right? Before, I want to say at .NET Conf, I forget if it was .NET Conf or if it was the last build, that Blazor server was generally really or made generally available. And WebAssembly still was sort of in the works and it was still in preview, but as of yesterday, it is now officially released. So that was cool. But related to WebAssembly and being able to sort of run code in one place, I saw this from the community, which and it's related to web tools, and I don't know when this is from. Let me see if I can see when this is from. I don't know if it'll tell me the date of this. Not footer, no. Head. Yeah, it doesn't tell me the date, but this thing was written years ago by Thomas Petracek, who I think he's now the director of the F# Foundation. Anyway, this was many years ago. And what he was trying to do was he was trying to, at the time, use Ajax, right, and use F# to essentially write code or have code that runs both on the server and on the client at the same sort of, use the same language in the server as well as on the client, right? So you can think of in JavaScript, that's Node, right? If you think of C#, that's Blazor, right? With WebAssembly, and stuff like that. And you can tell that this was a while ago because at the time during his internship, the F# team was working on this feature called computational expressions, which those have been around for quite some time in F#. So, yeah, but it's really cool that these ideas, right? Like they're not necessarily something. I mean, I'm sure the technology has gotten better, but it's things that have been in people's minds for quite some time, and just being able to sort of see these things, and seeing sort of the origins of a lot of these things and how people were doing it before, it's always eye opening, and it's always really interesting to see. Let me see. No. Forward. There we go. Yeah, so Rich Cloud Web Applications. I guess there's a paper on it, and download talk slides from Microsoft Research. It's not available anymore. But anyway, this is cool. Anyway, that was like 40 minutes of me rambling on what was announced the build, but we are here to continue working on Stamina. So again, Stamina, static malware analysis using deep learning. What we're trying to do is we're trying to essentially convert binaries to images and then take those images and use transfer learning. We're going to be using ML.NET for this to try to classify malware. Okay, so last time we left off, let me see. Okay, that's not good because now I can't see this. I'm gonna have to go back to my other settings. There we go. CD Stamina. Yeah, this isn't helping. I guess I'm gonna go with this. And I'll open code, Visual Studio Code with this. So last time we ended up at this point where we had been able to get the images, but we couldn't. Sorry, we were able to get the bytes, right? But there were so many different ways that we were not able to actually get the images. So what I did was I kept, what was it, Friday, I think it was, that we did the stream. I kept playing with it later on in that day, and I think I was able to get it. And the way that I did that was, it's not exactly how I would want to do it, but it's a way to do it, and you'll see why. So notebooks, pod launch, foundation. Sorry, I'm just trying to find where multi-model, my custom pocket pod sample spark stylish. Where? Did I do this on the wrong computer? Oh, no. There it is. Okay, so I have this binary image. So let me kind of open... Let me open with Code Insiders. Not that it matters, but at least there's some distinction, kind of. Okay, so the way that I did it was... It was using this thing here. So first of all, create a new bitmap with the dimensions that I want. Set the resolution, and then just basically set each pixel individually. So if we do that here, let's see now. We're gonna cheat a little bit. So file.readAllByte. Let's see. So let's start off here by number one. Let's get rid of this here, right? And what we want to do here is, number one, let's just write a function that's going to take in a file path, which is going to be a string, and we want to essentially do this thing here, right? So that's going to be file.read all bytes, and then we're going to give it the file path, and then what we want to do on top of that is we want to convert it to a float, right? Why do we want to convert it to a float? I don't know. We want to convert it to a float because this is going to return to us bytes, and to set the pixels, we're going to need some sort of we're going to need a number, and I don't think it's going to like us having a byte. So turning it into a float, turning those bytes, which are going to be from 0 to 255, into a float, is going to allow us to operate and set those pixels much better. So let's do that. Let's create something as well. This thing here, right? So we want to be able to pad. We want to be able to pad our image, right? So pad image array, and then for this one, it's going to be what the padding is going to be, and then this is going to be first array float 32 array, right? So what this is going to do is it's going to take the result of these get image bytes, and it's going to then pass it in here, and it's going to pad this array with it's going to pad the array with zeros. Pad array with zeros. I think that's a little bit more descriptive. Okay, and then to do this, what we're going to want is we're going to want to say array.0 create, and it's going to be a float 32, right? And n is the number of zeros we're going to add on to the already existing array, right? And then we just say array.append, and then first array. Okay, so now we can kind of get rid of this, and we can kind of get rid of, can we get rid of this? Let's see, let binary file bytes equal to get image bytes, or no, get file bytes, right? Because it's not an image, this is a file at the moment. So we want to get the file bytes, and we want to do it on my binary.txt. Okay. So now that we have that, we know what our width is and we know what our height is. Eventually, we're going to want to dynamically set these based on what the paper says, but for the time being, let's go with 128 by 128 because we saw that that's what it should be. And then we figure out the dimensions, right? 128 by 128. I don't think I need this though. Do I? Yes, I do, because that's how I'm going to figure out how much to pad by, right? So it's going to be whatever 128 by 128 is, which is the dimensions of what our image should be. And then what we do is we subtract what we already have, which is going to be the bytes that we get from the file, and then pad the rest with zeros, right? So pad, and then what we're going to do is now we're going to call, let's see, let image bytes is equal to pad array with zeros, pad, and then this one's going to be binary file bytes. Okay, it's going to be binary file bytes, and we can always refactor this at a later point. I'm going to get rid of these because we're not going to be using ml.net just yet, right? We're not going to be using it just yet. Okay, so if I run this, I should expect to see, place a breakpoint here. I should expect to see a, let's see, what is it, 16.3A4, I think it was. 128 by 128. There you go, 16.3A4. So we should expect to see an array of 16,384 elements or values. Okay, so let's debug. Okay. Okay, perfect. So yep, the dimensions are 16,384. Our pad, because our original the bytes from the binary file are 43, right? 16,384 minus 43 is 16,341. And then if we do that, there's our image bytes. And there it is, 16 through 84. Okay, so all right, we're in good shape. So where do we go from here? Now we know we have the pad. How do we convert this into a how do we convert this into an image? So I don't know exactly what this is for, to be honest. I saw an implementation of it. It's one of those things where you kind of copy and paste. I mean, I could kind of reason about what it does, but so let's write it out first, and then let me just cheat because there's. So essentially what it's doing is it's trying to find the individual pixel, and it's trying to set the alpha, the red, the green, the blue values for that particular pixel, right? So for each of the pixels, it's trying to set the alpha, red, green, and blue values, right? And the position is it's basically the pixel that it's iterating over as part of this image bytes array, right? So the first thing that we need to do here is we need to set default values, right? A, R, G, B. And I'm going to set this one to 255, 0, 0, 0. And what gets returned here is a tuple, by the way. So when you have comma, 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 or you have values separated by commas, this is a tuple, essentially, right? And if you can see here, the type signature, let me actually make this a little bit bigger. If you see here, right, this is a tuple with 4 values, okay? So, and here we're creating a tuple. Well, or we're deconstructing these values or setting these values individually. It's A, R, G, B, and there's going to be 255, the highest value, and set everything else to 0, okay? So now what we want to do is we want to, first of all, create a new bitmap. DST is equal to new bitmap. And we want to set this bitmap dimensions, the height and the width, to those specified up here, right? So we're going to create a new bitmap that has 128 by 128 dimensions, okay? And then now what we want to do is we want to just iterate through each of the values here, right? So the image bytes, or the I guess image pixels might be an even better term for it, right? And what we want to do is we want to iterate through them. So for y in 0 dot 127, or better yet, 0 127, do for x in 0 127, do. So first we get that position, right? So this is expecting the position, which is going to be the index of the pixel where we are at, right? So let let position is equal to y times 128 plus x. Okay. And the reason why we do this is because, right, so let's see if I can 1 2 3 4 5 6, right? So let's imagine that we had a 3 by 2, or a 2 by 3, sorry. What this would do, the multiplying here, would essentially allow us to jump from row to row, right? So now we're, instead of being at position here, we're at this position, and we need to do this because we're sort of in we're using a one-dimensional array in this case, right, instead of a two-dimensional array. Okay, so let's see here. Okay, so now that we have this, now what we gotta do is we gotta get the colors that we're gonna set for that position. So it's gonna be A, RGB, and that's going to be equal to set colors, right? Image pixels, and then we do, what's the position? Position ARGB, right? So position, we get it from here, right? That's the index where we are at in the current, in this particular array of bytes or pixels. And then these are the original values that we set up here, okay? So once we have that, now we create a pixel. Go to color dot from ARGB, okay? And what this expects is our alpha value, our red, our green, and our blue. Okay, so there's that. Once this is done, set pixel, and we tell it at position X and position Y, set the pixel. Okay, so it's going to iterate. It's going to set the values for each of the pixels in my new bitmap. And then what I want to do is I want to say DST, right, my bitmap, save. And I want to save it to something called, I don't know, file image dot JPEG. And we want to set the imaging dot image format dot JPEG. Okay, so this should do the trick. So if we were to now go to the terminal, let's build it. What happened? Where? For one, let's get rid of this. Unexpected quote symbols at 44. Oh, this. There we go. That should work. Yeah, with this, the quotes are like, you gotta go after, because if you put them in front, I think that they mean that they're a generic parameter, right? Like if you're doing some sort of, you're defining the signature, that's used for, like, quote, the variable or the generic type, that's for when you're defining types or functions, right? The signatures, whereas if you want to use as a value, you want to do something like this. So .NET build. And then you want to .NET run. And let's see what this does. No. Run app. What happened? Index was outside the bounds of the array. Okay. So which one exactly? Was it this one? Right, because there's got to be 3 pixels. Okay. So what we did there was, instead of, so we did 128 by 28, 128, but we also needed the extra 3 pixels. So, or three pixels per three values per pixel, right? The RGBs. And when we take a look at that, right? Look at take it, check it out. There's our binary image representation. Is this right? I don't know, but it's something, right? Uh, this is something that we can now use as an image and do some image classification on. And yes, Daniel, yay, this is awesome. It's crazy that like it took me a while to try to figure this out, but I'm glad that I did. And now we're past the biggest like hurdle. Well, kind of. Now we just need to refactor this such that we are able to figure out what the height and width dimensions are depending on the size of the size of the array, right? The array length. And the way that we want to do that is, how do we want to do that? Stamina white paper. Okay, so this is nice. Localized at the beginning. Yeah, and yeah, Daniel, you're right, and it does seem to be all the way at the beginning, which it concerns me because it's gonna be biased towards looking at this area. Um, like it's gonna be biased towards looking at this area, and I'm concerned that it's not gonna be able to represent the data well. I think I think we should come back to this because I like although we did it, I don't think we quite did it right. Like we achieved the goal of turning a binary file into an image, right? The bytes of a file into an image. But I'm not quite sure that I think this is what it should look like. Let's try something. Let me see. Let me download. Go to my downloads. Notepad. Okay, so this is the name of our thing, PDF. Let's see what this looks like. Let me see. If I do where's my shell? There it is, my terminal. CD app. Oh, yeah, CP downloads. Stamina. Okay, do I have to do that? CUL down stamina scale. Okay, I'll copy it here. All right, so let's try it with the PDF. Let's see what the PDF looks like. So this was a text file, right? And our text file was really small. There was like almost nothing there. What would happen if I were to call it with stamina, the scalable, the deep learning white paper.pdf? So two things I want to check first. First, I want to check here. I want to debug, and I want to see what's the size of this thing. Like I want to see that. Okay, so if we step over that, file not found, debug. Oh, okay, yeah, I know why. Sure. And it's called what? This. And so we want to copy it to the output directory, and now we want to debug. Let's see. Okay. Step over. Okay, so now check this out. Now this is 619,956. So now it's going to get interesting because now we are in this territory here. So let's pull out Excel again. And let's give Excel some time to work. Let's see. So what we want to do here is we want to do what? What's the value? 6619956. 619956. So that's a pretty decent file. Now the height in this case would be 2048. So so this is going to be what? Our byte length. Okay. And this is our width, which is what? 2048. That means that our height will equal to what? This divided by that. Check that out. So now we're at 300 and round up. Oh, comma 0. So we're at 303. Okay. Now, what we're gonna need to, so this is our round height. What we need to pad now is this minus this, and everything else gets padded with zeros. Okay. At that point, yeah, we don't care because oh wait, we do care. All right, let's try this. Let's go with 2048 for this. Let's not go by what they're saying. Let's just see what it would look like if we were to do this. Terminal. Okay, so all right, so check that out. Oh, this is nice. I like this. It looks like I mean, it's still true what you were saying, Daniel. That why is this zoom so bad? You know what? Let me open it with photos. File Explorer. Let me open it with photos. Maybe the photos is going to be better. Open with photos. Yeah. So why is this? Oh. Okay. So here's our image bytes, and it's a 28 for. There it is. Okay. So we're getting what? So it seems to be working. What if I did this? What happened then? That it would look weird. But let's try it. I'm intrigued. Yeah, hold on. 20 would be 2048. This one would be 2047. 47. 47. 2048. Yep. Okay. Let's try this. Okay, how does this look? Very cool. Okay. They're interfering with values to predefine width and height, if I remember correctly. It is, yeah. So it is padded. Yeah, it does, and that's because I hadn't changed this here. But now let's see. So in this one we said it would be 303 for our height. Okay, so, and that's because greater than 1500, which in this case it is, it's 619,000, right? And we take our width, so it would be 619,000 divided by 2,000, which still gives us three something. All right, it gives us 303. Let's go with 303 for our height. And if I were to do that, right, what does it look like? Parameter must be positive, and width okay, so it doesn't like that. Parameter x. Why would it ever be negative? Oh, that's why. Cause so my y, my height would be what? 302. Okay, it doesn't like that either. Oh, I don't get why it's not positive. Let's see. Was positive and less than the width. Yeah, but my width is 308, 2048. Okay. I mean, I don't know at which point it's not positive, but let's see. 2048. You like 2047. And then this one's going to be 2048. I swear, this is the worst. I don't know why the camera keeps going off. I mean, not that you want to see my face, but let's see. Okay, I mean, I kind of like this. I still don't think I'm doing it right, but I like it. It seems to be working. Yeah. Cool. So let me go ahead and I'll leave this because I was actually intending on using the white paper as well. And let me actually just go here. Okay, there's all these things. Converted images or bytes to image. Okay, so let's do that. By the way, if where is it? It's not the one I was looking for. It's this one. So by the way, if you if you guys haven't checked it out yet, it's not mine. All of GitHub. Haven't checked it out yet. You definitely should take a look at this. Yeah, this is going to be a really cool project. If you haven't seen it already, I suggest that you do. But it's, yeah, something worth continuing to explore and play with from Alexander. But yeah. All right, so did all my changes push already? Yeah, I agree, Daniel. It's very good to contribute to that one. Oh, interesting. The Azure notebooks extract from that in the core. Interesting. 5 months ago. Okay, there's nothing on here, but no. Okay. All right, so let's see. So if we go back to mine, right? Dev, stream projects. There's stamina, app, and let's see. Beautiful. I like it. All right, so we got something done. I rambled most of the time here about all the cool stuff at Build. But yeah, it's still happening today. So I'm sure that there's tons of great sessions happening going on today, and you should definitely check them out if you can. We're going to keep working on Monday. We're going to keep doing the workshops in F Sharp. We're going to keep working on that. Stamina, I'm going to put on hold for a little bit. And actually, wait a minute. Monday. That's Memorial Day here in the US, which means holiday. Won't be able to go to the beach, but at least it's time off. Yeah, so I guess maybe not Monday. We'll see if maybe we do Tuesday or actually Friday. I don't know. I'll see. And set something up, and then we can either continue working on this, continue working on the workshops, or maybe we just pick up a new project altogether. That's too much. We'll keep working on one of these. Anyway, thanks for joining, and I hope to see you soon. Thanks. Bye.